Today we're going to be talking about quotient properties of radicals and how we're going to simplify radicals when we have a fraction underneath our radical. Now, something that you need to realize is a radical can be simplified on the top and bottom, so that radical can be moved to the top and the bottom. And so therefore, you can also go the other way. I can make this radical here the square root of 27 over 3, which would simplify to be equal to 9, or simplify to be 3. Same thing here. I can simplify the radical. I can move my radical on the top and the bottom. The top simplifies to squared. The bottom is going to simplify to 2, so you simplify. Now, in both of these cases, we had a perfect square. We were able to simplify, so I didn't have radicals in the bottom. But this down here is super important. Please make sure you write this down. If your radical is just a perfect square root on the bottom, and you guys should remember this from Algebra 1 and geometry, when you have a radical on the bottom, you multiply the top and bottom by that radical, and that simplifies, because you'd have underneath here, you'd have the square root of 9. So that simplifies. But what if your radical was something other than 2? Something like a third. Okay? What happens here is we need, on the bottom, we need to get rid of that radical. We need 2 to the third. Here I only have 2 to the first power. Okay, I only have 2 to the first power. So I need to multiply by 2 squared. So I basically have there the cube root of 2 times the cube root of 2 again. Because when I combine those under one radical, you would have the cubed root of 2 to the third, which then simplifies to be 2. And remember, we need to multiply the same thing on the top and the bottom. That's why this 2 squared over here becomes 4. Okay, so let's do some examples involving these. Okay, simplifying our expressions. First, what I want you guys to do is first simplify any perfect squares you can pull out of that radical. Meaning, we have the square root of y to the 8th on top, and we have the square root of x to the 7th on the bottom. That simplifies to y to the 4th squared, because I multiply those exponents to get me back to 8. Now x to the 7th. Since 7 is an even number, 2 doesn't go into 7 evenly, I'm going to have leftovers. So I'm going to have x to the 6th times by x, which then that simplifies to x to the 3rd squared times by x. So then on the top, those cancel, the square root and the squared cancel, and I just end up with y to the 4th over, I have x to the 3rd, and then I have this root x that's still left over. Now we don't like radicals in the bottom, so now we need to simplify that radical. We need to multiply by root x over root x, because then I would have x squared on the bottom underneath my radical. So again, underneath the radical, we would have the square root of x squared. We know that that can then, the top is remaining the same, we know that that can then turn into x, so I would have x to the 4th. Okay, our next example. Now I have something to the third root. So what we have is we have the cubed root of 2, and I have the cubed root of 9x. Now, the challenging thing for you guys is going to be try and put that 9 to a certain power. Meaning try and put it to the highest power you can. Meaning we know 9 is 3 squared. To basically clear that root in the bottom, okay, we need to have 3 to the 3rd power underneath there. So I need to have 3 to the 3rd power. How do I get another 3 to the 3rd power? I just multiply by another 3, because then I can combine those to get 3 to the 3rd power. I have to do the same thing on the top and the bottom. This x here, this needs to be x to the 3rd power. I only have 1, so I need to add in another 2. So that, let's just worry about the bottom right now. So worrying about the bottom, 3 squared times a 3, that's 3 to the 3rd power. X times x squared, that's x to the 3rd power. Okay, so then just worrying about the denominator right now, that's going to simplify to 3x. Now worrying about the top. Since this root is the same, I can combine the 2 and the 3 to get me the cube root of 6x squared. There's no perfect cubes that I can pull out because 6 doesn't really have any powers to it. You can't break down 6 anymore into smaller powers, so we're left with 6x squared is our answer. So this whole thing here would be our final answer. Okay, multiplying radicals. Basically, this is just FOIL. Okay, just think about it like FOIL. First terms together. We would get the 2 times that 3 would be a 6 root 3. The outer terms together, you would have a minus a 2 times a root 9. Your inner terms together, 3 times 3, that would be a 9 on the outside, root 5 still on the inside, and then your last terms together, we would have a minus 3 root 15. Now simplify any radicals that we can. 6 root 3, there's no perfect squares that I can pull out. Square root of 9 is 3, so I can do 2 times 3, which would get me 6. 9 root 5, there's no perfect squares I can pull out of the 5. And the root 15 is just 3 times 5. There's no perfect squares I can pull out of there. So we're left with that as our answer. And that's okay. There's nothing I can combine. Even though 3 times 5 would get me 15, we can't combine because the radicals are not the same. Okay, simplifying with radicals in the denominator. Here I have square roots in the denominator. And we've actually done this before. We did this back when we were working with I. Okay, because I was really a square root. So when we deal with this, we do the square root of 6 minus the square root of 2. Remember, it was that conjugate. Because let's look at that denominator. Let's FOIL out that denominator. Let me show you guys. First terms together, we get 6. Outer terms together. Inner terms together. Last terms together. Those radicals cancel. That's super important. So then I'll FOIL out the top here in a minute. I just wanted to show you guys that when you FOIL it out, you're going to get no radicals on the bottom. Okay, now let's FOIL out the top. First terms together. The outer terms together, root 6 times root 2 is a negative root 12. Inner terms together. And then your last terms together, we would get a plus 2. So I can combine the 6 and the 2 to get me 12. No, not 12. 6 times 2 is 12. You want to add. 6 plus 2 is 8. Here I would add negative 2 root 12 because I have 2 root 12s that I can combine together. Simplify this root 12. Root 12 can be broken down into 4 times 3, so that would be 2 times root 4 times 3. The 4 can become a 2 outside, so that's why I have a 4. 2 times 2 is 4. Root 3 all over 4. Now remember, to simplify this, the same number needs to be factored out of all the numbers. Or write it like this. Eight over 4 simplifies to be 2. 4 over 4 simplifies to be 1. Root 3. Okay, there are your lesson questions. I apologize. Some of those are kind of small to see. Try as best you can, and make sure your lesson summary is submitted on time.